Hello, good people. Today I want to talk about quadratic equations and expressions. I want to help you or show you how to do an expansion of quadratic or basically quadratic expressions. I'm going to go through the whole topic, but what I want to do in this particular clip is to show you how to do expansion of quadratic expressions. And then when we are able to know how to expand quadratic expressions, we will also try to check on how or the easiest way to do this using what we call quadratic identities. Before I start to practically show you how to do this, I wanted to make you understand, or rather, I wanted you to be able to differentiate between quadratic equations and quadratic expressions. We try to understand basically what is an equation and what is an expression. For you to understand quadratic equation and expression, you need some prior knowledge on linear equations. So basically, it would be of great importance to try to do a recap on what you call the linear equation. So what is a linear equation? What is a linear equation? I know you're trying to remember where you've done this. Basically, linear equations have been introduced to you before quadratic equations, and these are basically equations of which are linearly in nature. In other words, when you plot the graph of linear equation, they are basically of the form y equal to mx plus c, and they can also be written as ax plus by equals to c. In this case, a, b, and c are constants. Then x and y are variables. These are variables for the equation. So in this case, m presents what we call the slope, and c is basically the what you call the y-intercept. Basically where the curve, when you plot a graph of this equation, is going to be a straight line, and where that line cuts the y-axis is what you call c, which is a constant value. Then x and y remains variables, as I had told you before. So linear equations are equations of the highest power 1. Highest power 1. Now when you go to quadratic equations, then quadratic means highest power is 2. So for that case, quadratic equations are of the highest power 2. And these are expressions or equations of the form ax squared plus bx plus c is equal to y. So this one is a quadratic expression. In other words, y is written in terms of x, just the same way we did in linear equation, whereby we say that y is equal to mx plus c. We can also write a quadratic expression in terms of y, and that is basically going to be this. So this particular expression here, which is quadratic in nature, is called a function of y, which can be written as f of x equals to ax squared plus bx plus c. It is important to note that a, b, and c are constants. So a, b, and c are constants, and it's also important to note that the powers of the variable x are decreasing. So this one is x power 2, this is x power 1, and then we usually have x power 0. In other words, this is simply ax squared plus bx power 1 plus cx power 0. But remember that indices will tell us that any number n to power 0 is always equals to 1. Therefore, x power 0 equals to 1. And therefore, when you take 1, you multiply by c, you remain with a c, which is a constant. So therefore, there is no need of writing x power 0. And that basically why we don't write it when you're writing a quadratic expression. Therefore, what is the difference between an equation and an expression? An equation, like look for instance, these two, we have ax squared plus bx plus c, and then we have ax squared plus bx plus c equal to 0. So this one is an equation, and this one is an expression. Looking at these two particular expressions I've just written, you can clearly be able to see what makes this one an equation. Basically, this one has an equal sign, but this one does not have. Therefore, an equation must have an equal sign, but an expression does not necessarily have an equal sign. So basically, that's the difference between an expression and an equation. So today what we are dealing with is basically how to perform expansion of quadratic expression. For us to be able to get a quadratic expression must be having a factor. So when a quadratic expression is written in a factor form, for instance, we can have an example here. Expand the following to simplest form. Simplest form simply means that you have to make sure that the values are 2, all the like terms are put together, so that you can be able to have an equation or an expression in its simplest form. So basically what we're going to have now, we get an example, and for that case I can have a 2x plus 3 into brackets, then we have x minus 2 into brackets. This one is an expression which is written in what we call the factor form. So it's written in factor form. So to expand this particular expression, what we're going to do, we're going to have, we take the first number here, which is 2x, we multiply by what is here. And then we come back to, we pick this, we multiply by what is here again. So in other words, every number in this particular first bracket must be multiplied by every number in the other bracket. So what are we going to have? We're going to have 2x, okay, we multiply by here, so that is going to be into brackets, x minus 2. Then we come back, we pick what is remaining. We have already picked 2x, which is here, so we now pick the 3. So we have plus 3. When you're writing that one, is also important to make sure that you consider the sign which is written here, to make sure that you don't mess up with the sign, because if it was minus here and then you don't write that particular subtraction here, then you mess up the whole thing. So in that case, we go to have plus 3 into brackets x minus 2. Close the brackets. We expand by simply multiplying or opening the brackets, and this one becomes this type, that is 2x multiplied by x, 2 times 1, because the coefficient of x here is basically 1. So we're going to have 2 times 1, which is 2, then x times x, which is x squared. Then we have 2 times 2, which is going to be 4, so we have minus 4. Why? Plus minus gives us minus, so plus 4, but we have x, so x times 1 remains to be x. Plus, we have plus times plus, that gives you the same, so 3 times x, which is going to give us 3x. And then we go to have 3, we multiply by negative 2, which gives us negative 6. Remember, positive multiplied by a negative gives us a positive, multiplied by a negative, remember, will always give us a negative. And that's why positive 3 multiplied by negative 2 will give us negative 6. So when you're done with that particular part, what we do, we try to check if they're like terms. And in our case, terms are like terms if they are the same in the nature that their powers are the same. So if we are, for example, numbers are always like terms because you can always add or subtract or multiply. You can perform some computation on numbers. So therefore, numbers are always like terms. But when it comes to letters, letters are like terms if they have a common power. When you look at this one, this is x squared. This is x power 1. So this is not like term with this. But x and these are like terms. So in this case, if you have like terms, we consider the numbers, we perform normal computation. In that case, we go to have 2x squared minus 4 plus 3. That gives you minus 1x. But you don't write 1x. So basically what we're going to have, we just write x. Because writing 1x does not have any meaning. So in that case, we have then now minus 6. There is no more like terms, and therefore this one becomes our expansion, which is a quadratic expression as I had shown you here. So we now move on to example number 2. So we can have example number 2. Let me call it B. And for that case, I'm going to have 4x minus 3y into brackets. We multiply this one by 3y plus 2x. I want to see, I've done some changes here. I don't want the arrangement like we have done here. In this particular case here, we had written 2x and then x. In this case, I have y, but I made sure that I start with x here and then I don't start with x on the other side, so that we can be able to see what really happens if we try to alter the arrangement. So in that case, to do this one, the same procedure is going to be followed. So we're going to have 4x. We multiply this one by 3y plus 2x. Then you come back to this. I said always remember the sign, so we pick the negative sign here, very important for us. And that case, we go to have minus 3y, and also we multiply again with what we have here, that is going to be 3y plus 2x. Now, to expand this one, we know that what we're supposed to do is to open the brackets, so we go to have 4x times this. So in this case, x and y are not like terms. 4 and 3 can be multiplied. So we multiply 4 and 3, which would give us 12. X and y cannot be multiplied, so we have x and y. We come up to this one now. 4 times 8 can be multiplied, which gives us 8. Then x and x, when we multiply, will give us x squared. We move on to the other part, and that is going to be negative 3, positive 3. So negative positive gives us negative 9. Then y and y will give us y squared. We move on to the next thing. We have minus 3 plus 2. When we multiply that one, will give us negative 6. But we have y and we have x. So this one becomes x, y. I know some people ask me, why did you write xy instead of yx? Arrangement in multiplication is important to know that does not matter. Why? If I take, for instance, x, y is the same as simply saying yx. Practically, this means 2 times 3 is the same as 3 times 2. So arrangement does not matter when it comes to multiplication. It's important to make sure that you note that. So therefore, back to my question. So I have 12x now, y, and I have 6xy. I have 8. So we try to look at, do we have any like terms here? Sure we do. When you look at 12xy and you look at 6xy, this one has x power 1, y power 1, x power 1, y power 1, x power 2. So this one is not a like term to another, so it can remain the way it is, and this one becomes automatically 8x squared. We move on to this one, plus 12xy, y plus, because this one indicates a positive, but you don't write positive a number. So that is going to be plus 12xy. Then we have minus 6xy. Then now minus 9y squared. Some people might ask me, and how come you brought this one here and you did not change the sign? We only change the sign if a particular variable or a particular number cross what you call the equal sign. But since this one is not it's not an equation, it's an expression, then the signs are supposed to be retained as they are. So in that case, now we're going to have now 8x squared. 12 minus 6 is going to be plus 6. then xy remains. Then now we have minus 9y squared. Looking at our expression now, you can be able to see that there is no more like terms, and therefore this one becomes our required expression, which is a quadratic expression. Let me give another example. Example C. In example C, I'm going to consider a different scenario, and for this case, I'm going to give you 3x plus 2, which is in brackets. This kind of equations is important. I know that we call them perfect square, but I'm going to talk about them when we move on to quadratic identities, so that I can be able to break it down. You understand better what is the meaning of that. So an expression in which can be written in that form, that is basically a plus b squared or a minus b squared, are called perfect square. But we're going to talk about more about that. So in this case, this expression simply means 3x. I know some students might be tempted to say 3x, the square, then plus 2 squared. This one is wrong, because this particular expression simply means it is 3x plus 2. You multiply by 3x plus 2. And once you write like this, we can be able to perform the same expansion like we were doing in this particular part here. So what you're going to have now is 3x, we pick the first one, minus, or rather plus 2, sorry, we get to have the first expression, sorry, we can have, okay, let me cancel that one. We can simply have 3x into brackets, we multiply by what is here, and that is 3x plus 2. Then we pick 2, so that is plus 2 into brackets, 3x plus 2. Expand it, this is going to give us what? I know this one now you are okay. So this is going to be 9x squared. We can move together, and this gives you 6x. Then we move to the other one, which is going to give us 6x also. We move also this and this one, which gives us 4. And collectively the like terms, this and these are like terms, so we're going to have 9x squared plus 12x plus 4, which is our required quadratic expression, not equation, expression. Remember, I told you that an equation must have an equal sign, and therefore this one is a one-way or one-sided expression. Therefore, it cannot qualify to be an equation. So today I try to make you understand how to perform simple expansion of our quadratic expressions, and I also try to tell you what is the difference between an equation and expression, so that you can be able to understand what is supposed to be done. That is just an introductory part of quadratic equations and expression, which is basically our topic. So I'm going to give you some few questions for practice purpose, so that you can be able to know, or to see if you can be able to get them after doing some practical examples, which you have done, the 3 of them. So I'll give you 3 questions here. You can expand the following. Expand the following. So we have A, just a simple question, 4x minus 8 into brackets, 2x plus 3. Very simple question. Question B, half x plus 1 into 4x plus 5. And then lastly, we can have 0.2x minus 3 squared. I know someone might be afraid, these things looks different from what you have done. For you to be able to know if you have got the concept well, what you have to do is, I tell my student to do a very simple task, and that is repeat what we have done exactly as we have done. Try to see if you can get the questions without looking at what you are doing, on your own. You create the questions at a different page. You try to do them. Find out if you can get them. Then after that one, come and try this particular practical quiz, and you'll find yourself very okay. You can as well get more work to make sure that you are perfect, and this is going to be a walkover. Now, once we meet again in the next clip, I'm going to talk about quadratic identities, how to do simple expansion. The same expansion, there is a shortcut. So I'm going to show you the shortcut on how to do quadratic expression, how to expand them easily, as well as how to factorize them back to what we have. Thank you very much, and make sure that you subscribe to our channel to make sure that you are notified immediately we are able to post our tutorials. Thank you very much, and let's keep learning. You know, when it's time for maths, numbers must be at play. Thank you.